When astronomers refer to dark matter, right, we mean something that doesn't interact with light in any way. It doesn't give off light, it doesn't absorb light.
Scientists like Clow think dark matter makes up 20-some% of our universe. But there's something else they aren't so sure about.
We don't know what dark matter is. We think it's probably some sort of particle that we haven't discovered yet, but it might turn out to be something different. We're not entirely sure.
So why is Clow convinced that it actually exists? Say hello to the Bullet Cluster, two immense groups of galaxies billions of light years away that offer some clues in the dark matter mystery.
So the Bullet Cluster is actually made up of two separate clusters of galaxies. About 100 million years ago, gravity has pulled them together and smashed them into each other. So in this collision, we have these two types of matter. We have the galaxies, and we have the 100 million degree gas, which sits between all the galaxies. 100 million degree gas, yeah.
So what, you might be asking, do the galaxies and gas of the Bullet Cluster have to do with dark matter? Let's create a mini Bullet Cluster collision to demonstrate, and here to help is Neil deGrasse Tyson.
So when we take these two separate clusters of galaxies in the Bullet Cluster and smash them together, the galaxies continue straight on without really any effect. The gas clouds, however, are going to behave just like any other sort of gas, and so they actually do collide. This is going to slow them down. And so now when we look at this cluster about 100 million years later, the galaxies are moving faster than the gas clouds, and so they're going to be further away from the center of this collision.
In the center of this collision are the intergalactic gas clouds, lagging behind the faster-moving galaxies.
The galaxies are now in a physically separate part of the sky from what the gas is. And so we've separated out the two types of matter which we can see.
Now here's the important part. Matter creates gravity. More matter, more gravity.
90% of this matter is in the gas cloud, and so that is where the gravity should be.
But when all the data was put together, that wasn't the case.
Instead, we see that most of the gravity is actually around the galaxies. And that tells us that something else has to be there causing this gravity. It can't just be the stars and galaxies themselves.